I've been teaching for a long time at UNISA in those parts of mathematics and physics which are applied to astronomy. So not general mathematics or general physics, only those sections applied to astronomy. And for instance, in mathematics that was spherical trigonometry, spherical astronomy, and perturbation theory, and stability of star systems. Good morning.
How are you today?
Reasonable.
I would like to speak to you, if you don't mind.
Outside or inside?
Oh, inside, please.
Yes, come inside.
Is this your room, sir?
Yes.
How long have you stayed in here?
About 20 years.
20 years?
Yeah.
Oh my god. And all these books?
Yeah, but it is not a variety of subjects. It's mainly mathematics, physics and astronomy. It is an hypothesis, as if the hypothesis says that presumably the whole universe started as an enormous explosion 15 times 10 to the power 9 years ago. That means 15 times 1,000 million years ago. You may believe it, you may doubt about it, you may disbelieve it, anything you like. You're right entitled, every person is entitled to believe it a little bit, to believe it strongly, to doubt about it, to have strong doubt about it, to disbelieve it. It's up to you. The people that do research on that are called cosmologists, and they are not of one common opinion. Every theory there is this or that cosmologist who believes it, and another theories, other cosmologists who believe that. So there is not a common opinion among cosmologists whether the Big Bang is correct or not, and whether you must believe it strongly or a little bit or not so strongly. And but it's up to you to believe. There is a great difference of opinions between the various cosmologists. One reason why some of them doubt about it, if it started with the Big Bang, what happened before the Big Bang? And so that is still uncertain. To give you an example, one of the greatest problems yet at the moment, now, that is the great difference between quantum mechanics and relativity. Relativity applies to what happens on a large scale, but quantum mechanics, what happens on a very small scale, on atomic scale, and smaller than atomic. You need hypothetical formulas in space of 8 or 9 dimensions to explain that. So the greatest trouble now between physicists is how can you overlap quantum mechanics, which applies to small distances, small particles, and the theory of relativity, which applies to on large distances between large stars and black holes and so. Entropy, that applies mainly to gases, but also to a certain extent on liquids and solids. The most important difference is the fact that entropy has induced, that in contrast to gravitational attraction, where stars move around each other, for instance, and where you can put the time in reverse and then get the same orbits. If you deal with gas entropy applied to gases, then you cannot reverse the time, because what happens to the gases as a result of entropy theory, that is different into the future than into the past, and you can it was different phraseology of the same thing. That the evolution that gases appear, also the mixing of gases, that is more and more mixing, that is more and more a situation of a higher probability, that is different in the future from if you reverse the time into the past. In contrast to, for instance, double stars, which revolve around each other, there you get the same orbits if you take the time running into the future or reverse into the past.
Why can't the entropy be functional with politics?
Because the history in future will be very different than if you reverse the history to the past.
How is that? How will I be different then?
Because there is no, there is no mirror effect. What goes to happen in the future is not a mirror image of what happened in the past.
So is there a mirror effect in the present?
Only in star orbits and planetary orbits, yes. They move very much the same in future as in the past. That's not 100% correct, but that is very close to correct. But in gases and in entropy and in the history of people, there is not such a thing as mirror effects, no. But even time is a relative effect. There are, to give you an example, if you are in the cinema, in the bioscope, then you see a scenery on the screen which develops. It takes 2 hours or so, you see the film there. But the whole film is already in the machine,
yeah.
in the projector. So if you take the whole film out, then you can see the whole history of what's going to be shown on the screen. You can see it in these series of photos in the projector. Now there are people who have the gift, who have the transnormal gift, that they can also see part of the future simultaneously with the present. What? These people are called paranormal also. Paranormal, supernormal, normal visions.
They're greater than number?
The higher gifts these people have, the smaller is their number.
Why?
That's always so. The better soccer players you investigate, the fewer of them there are. The wealthier people there are, you investigate, the fewer of them there are. The better chess players, the better mathematicians, the better soccer players you investigate, the fewer of them there are. If you investigate not so good, worse and worse soccer players or mathematicians, then there are more and more and more of them. Now, roughly in the year 50 to 60 before Christ's birth, the Roman Empire came into being, and that encompassed what is now called Italy, Switzerland, France, Spain, Portugal, England, not Scotland, England, the Netherlands, Belgium, West Germany, Austria, and the Balkans. Yeah, they had a decimal system. That means from 1, 2, 3, up to 10, and then you get 11, 12, and so up to 20, and then up to 30. So the decimal system. But there were all kinds of tribes here. Germanic tribes and Wallach tribes and Celtic tribes, which had different systems. Some counted only to 1 to 8, and then again from 9 to 16, and then again from 17 to 24. So not into decimal system, but 8, and others had it count from 1 to 12, and from 13 to 24 and so. And still others and did it from 1 to 20, and then from 21 to 39 and so. The reason is that before the Romans came, there was no money and there was no equipment, so you used your fingers for counting. Yeah, and some tribes used the 10 fingers, others you used the fingers without the thumb. That means only 8 fingers. Another used the 20 because you have 10 fingers and 10 teeth as tools. Yeah, you have 10 fingers on your arms and 10 fingers on your feet, and use those for counting. To give you an example, one of the greatest problems yet at the moment, now, that is the great difference between the sketch, quantum mechanics of a sphere, and relativity are not general mathematics or physics. Use context putting an Earth at the center of a very small scale. On top, for instance, mathematics that was spherical trigonometry, spherical astronomy, and perturbation theory, and stability of star systems. A sketch of a sphere, then usually, and you teach spherical astronomy to students, then usually you start with putting the Earth at the center, using the planets and the stars that you see from the Earth against that sphere, the celestial sphere. That is the first step in determining celestial coordinates of the stars. Coordinates longitude and latitude, or right ascension and declination, or azimuth and elevation or so, depending on the basic circle that you select on the sphere. The basic circle may be your own horizon, or maybe the celestial equator above the Earth's equator, or maybe the ecliptic, that is the orbit of the Sun as the Earth sees it, or the orbit of the Earth as the Sun sees it. Yeah, if you look from the northern hemisphere, from Europe for instance, you look at Orion, then it looks like a man who is standing. You see his torso, and his shoulders, and his head, and his legs. These are all indicated by stars. Not if you look, if you look from the southern hemisphere, it still looks like a man, but if he's more or less upside down. Why are they called stars? Because they're very stable. The next day they have the same position, and the next year also the same position. It is not 100% correct because they do move a little bit, but in the early time of the early Greeks, let's say 3 centuries before Christ, they did not have telescopes yet, so the stars looked fixed to the celestial sphere, as if they are not moving with respect to each other. And that's why they're called stars, or stellar, or astron. That means stable. Stars is the same stem word as stable, stationary, stable, stability, standing, and so, and still. The word planet is related to, in English, flat, field, plane, plasma, plankton, plant, but an even plunge. The original meaning of that word was expanding. But some of the old come from the same word, something like plunge, that ape men used when they throw something into the water. They plunge, and then the original meaning seems to be expanding. But there were many words that came from it, and some of them get a little bit different meanings. For instance, the plant. The plant itself is not moving, but it expands itself by growing other plants. If you put a plant somewhere, after a while you get more and more plants of the same family around it. So you have triangles, and you have formulas. The triangles have sides and angles. This is triangle, and this is triangle, and this is triangle. And then you have certain formulas between the values of the sides and the values of the angles. The formulas are somewhat similar to plane trigonometry, not entirely the same, but and not entirely different, but somewhat similar. And that B and that L, that mean that Greek B and Greek L mean latitude and longitude, and the Greek D and the Greek alpha mean right ascension and declination. Sky. This represents the whole sky. This represents the celestial sphere. And then these are circles which are used as coordinate circles, like the celestial equator above the Earth's equator, or the ecliptic. That is how the sun moves as seen from the Earth, or the Earth moves as seen from the sun. And then the stars are somewhere here, for instance, away from the equator and away from the ecliptic. That means a little bit north of the equator or south, and north or south of the ecliptic. Coordinates from one system into another, for instance. That's one of the many things that you must do.
When the sun sets, there you see, and then it makes a circle. It's like a door, you know. It is as if you can jump to the other side and find a new space that side, different from this one. Even sometimes like there, you know. Sort of like a windows of heaven. You know, but we know that heaven is on earth, you see, but it's sort of a window of the sky. And